Good morning, friends. We are back here again after completing 3 courses, namely Airplane Performance, Stability and Control, and Introduction to Experiments in Flight. Now we are here to start a course on aircraft design. Primarily, we will be focusing on the conceptual design based on aerodynamic considerations. We'll be mostly talking about performance related issues in designing an aircraft. Yes, we'll be talking more on civil aircraft, civil transport aircraft. We'll be also discussing how to design the aircraft so that it is having right type of handling qualities. In turn, we'll talk about how to lay out wing, tail, vertical tail, horizontal tail, so that we have right amount of stability margins, its damping ratio, its natural frequency, which already we have some exposure. This is the time to synthesize whatever we have learned in earlier 3 courses. Before I start this course, let us understand our country has produced space vehicle or launch vehicle, satellite launch vehicle of various capacities. We recently had Mangalyaan, a wonderful venture. We have deployed 104 satellites in particular orbit. All these things talks about the synthesis of design. At the same time, you could see we have a lot of success in designing missiles, including air defense missiles, ballistic missiles. We also have tremendous success on fighter airplane, light combat aircraft, which is LCA, and country is also moving forward towards the next version with higher capacities and capabilities. But you will see that we have not really done enough as far as designing of civil transport airplane. And that is where this lecture is dedicated to. Can we, through these courses, make design a popular course so that younger generation can get inspired and empowered technically, so that they can add values and convert this understanding to technologies, and maybe next 10, 20 years, we will have our own civil transport airplane. With that understanding, with that motivation, I thought I will again interact with you and share with you whatever I understand in terms of aircraft design. Please understand that when I say we haven't been able to produce a really good civil transport airplane, I am not undermining that we have already developed Hansa 3, a trainee aircraft, of course under NAL, National Aerospace Laboratory. We had some success with Saras airplane, but for an unfortunate incident, which is a part of development. And I am sure NAL will come up with new ventures. But the question comes, are you ready? Are you really creating right type of manpower who will be able to take these challenges? And this course will help in a smaller way to fulfill that requirement. Coming back to these courses, in particular aircraft design, we need to understand ourselves what are the immediate thing that comes to our mind when we see an aircraft. For example, if I am seeing this aircraft, which is Sinus 912, a motor glider, if I see this typically as a passenger, a joyrider, my first focus goes towards this propeller, which is the engine side, and the propeller rotates and creates enough power to take it out, give a proper speed to the airplane so that it can generate right type of lift. But for a passenger, what comes to his mind? The moment he sees a single propeller airplane, he thinks, oh my God, So only a single propeller. If something happens, what will happen? So that is the impression a passenger gets. He doesn't get much bothered about seeing the wing or vertical tail. For him, immediate psychological focus will be on the engine. For example, he will ask, what is a single engine? What will happen if the engine starts off? But now think, same aircraft when viewed by a maintenance engineer. He starts looking to every component. For him, yes, he puts enough inspection to ensure that this engine is airworthy, reliable. He also looks for the wing. He looks for this Peters tube, because you know this Peters tube will tell you what is the air relative speed the airplane is having. So he'll take extra care to see that the Peters tube is not blocked because of some foreign particle, and that is why some covering will be there as a part of mandated regulation. So for an engineer, he sees purely from maintenance angle. He is not bothered about whether this design or this angle of the landing gear is okay or not. For him, he believes, he starts from that point that design has been done properly. He looks from the maintenance point of view. He'll be checking whether, when the aircraft lands, whether the landing was proper or not. There are many occasions where landing may be heavy landing. So he will immediately come and check as per the maintenance schedule whether the landing gear is okay or not. He will be also checking, if you see here, checking these ailerons, these control surfaces, similarly elevators, rudder. He will see whether when the pilot moves it with the stick, whether these things are being deflected proportionately or not as per the manual. But the question comes, the basic question which comes to our mind in this course is, how much it should be deflected for a particular mission, and how much stick force the pilot has to apply to deflect this up and down, or the elevator up and down. That should be properly designed, and before you design, you do a proper evaluation. And once you say, okay, this much of area I need of the wing to be aileron, then comes the next. A designer will see whether standalone aileron size is okay, but when I fly the machine, when this aileron deflection also gets coupled with yawing motion, because ailerons are primarily for roll motion, right? But as it rolls, it yaws also. So it will also create some yawing motion on the airplane, and then you have to correct it through rudder. So a designer will see the effect of each individual, not only separately, but also as a cumulative performance. And that is a good design when you take the advantage of each component effectively and make the whole airplane worthy as per the handling requirements dictated by design parameters. Please do not forget, whatever airplane you design, finally the pilot will be flying. So when the pilot flies the machine, when he touches down, he should tell, oh, it's a wonderful machine, lovely to fly. He should not say, oh my God, what is this aircraft? I have to pull, I have to give so many of forces to deflect the elevator or aileron. I'm getting tired. So all those inputs are to be taken to finally design an airplane. If it is from that angle, the second angle you understand that, okay, I would like to go at a particular speed, I like to fly at a particular angle. The question comes whether structurally it is good enough to withstand that much of aerodynamic load or not. It should not happen that as I deflect the aileron starts deforming, right? Then the aileron will not be effective. So that part is taken care by the structural designer. You could understand this is typically like a cantilevered wing. And if there is a load here and if there will be bending moment at the root, there may be a torque acting on the wing. So the wing should not deflect unnecessarily, or whatever deflections are there, we should be able to estimate it and apply appropriate corrections, right, in the design. If we further see from a designer point of view, this portion, the huge, large span, you know it's a wing, and the question comes to our mind, the wing is primarily to produce enough lift to balance the weight of the airplane. The moment we think of wing producing lift, first thing comes to our mind, what will be the area of the wing which will be able to produce the lift at a particular speed. So when you see the wing, yes, first impression comes how much will be the area of the wing, but then we also know that it's just not the area, we have to also see what is the aspect ratio of the wing, because we know that as I increase the aspect ratio, the induced drag component reduces, right? So that impression comes from the area part, okay? But at the same time, you know that I want to ensure that the lift to drag ratio for the wing is comfortable the way we want it, and there we go for aerofoil, right? If I take a cross section like this, we'll discuss, and you know that the whole art of selecting aerofoil becomes very, very important in designing the wing. And when you try to see an aerofoil or select an aerofoil, we primarily see how effective it is in terms of lifting and what are the penalties you have if you want to increase its lifting characteristics. What sort of CL by CD the wing is supposed to give. Another important thing is what is the stall angle, right? Because at what angle the wing is supposed to stall. And how do I design or customize the aerofoil so that either few of these parameters are optimized, or sometimes we give more weightage to the stall angle. So all these combinations will decide what sort of aerofoil we will be using. We will be talking in detail in our design exercise in the classroom. But before you design, it's important that you try to appreciate things without using a formula, right? It should come from your heart. Yes, I want this. I'm looking for this, right? Now from wing, if I come here, this is the horizontal tail, and you know this is elevator, this is a vertical tail, and this is rudder, okay? So it is also important to find out what should be the horizontal tail area, how much of this horizontal tail should I use the area as an elevator, or should I use complete horizontal tail as an elevator. You know, when a complete horizontal tail is used, we call it a all movable tail, right? Similar thing is here for rudder. This vertical tail, the 40% of vertical tail will be rudder, 50%, 60%, or all of this area. These are the primary decisions you take before you start conceptualizing a design of an aircraft. Now this, whatever I have told you, is from the configuration point of view. But what is the role of the wing? Is it only to give lift and drag ratio the way you want it, the way we want it? Is only the role to give enough area to get enough lift? Let us understand this. We will go to another aircraft and try to address this question. So we were discussing about wing, and primarily we are talking about the area required, the aspect ratio, the aerofoil, from aerodynamic consideration. But you see that if this is an engine which is driven by fuel, combustion engine, then I need to have fuel carried in this airplane. So I need to have a fuel tank. Please see here. This is one of the combinations, or design combination you'll find. People are putting fuel tank inside the wing, right? That means it is just not selecting an aerofoil. We need to see that when I translate that into a wing, I should have enough volume to accommodate this tank. So that also decides what will be the thickness of the wing and what sort of aerofoil I will be taking. right? Because each aerofoil has got thickness to chord distribution, specified distribution. And when we talk about the fuel tank, you will understand I cannot locate this fuel tank anywhere randomly, because this has a weight, almost 30% of the weight of the airplane is the fuel. So its location will determine the location of center of gravity of the airplane. And more importantly, as we fly, the fuel gets consumed. So if we are not clever enough, then what will happen? As the fuel consumed, there will be large variation in the center of gravity of the airplane, and which will directly affect the stability of the airplane. You know that stability and center of gravity locations are related. So a lot of effort will go in designing an wing aerofoil combination, keeping the housing of fuel tank. So what by this I am trying to stress is, this is real synthesis. What is important, you should know each standalone characteristics, but you also should know that I have to do multiple things and try to satisfy everybody, which generally is not possible. So there is something called, we try to optimize, or sometimes we call, okay, optimization in true sense may not be feasible, but we say, okay, it is adequately optimized, right? Now, beyond aerofoil and fuel tank, if you see these ribs, they actually maintain the contour of the wing. And the question comes, how many of such ribs should be there? How many of load bearing member, longerons, etc. will be there? Because after all, it will be always having a bending load or a torsional load. How do I distribute those load across the member through this sort of a structure and ensure that the airplane is safe structurally? That's why it's extremely important that I not only design a wing through aerofoil and aspect ratio, I need to go inside the wing and see the volume available for accommodating fuel tank. I need to know how do I place the stiffener inside the wing, how do I put the longerons inside the wing so that it is structurally enough strengthened, right? And again you could see aerodynamic structure in fuel tank. All these three things have to be integrated, synthesized, keeping one mission that my airplane should have particular mission requirement. What are the mission requirements? How do we decide? We will be discussing inside the classroom. This is important thing as far as wing is concerned. But if I ask you a question, if this is an airplane, out of this airplane, you will see the engine part. Engine part, we do not make any engine, right? So, in fact, not very large number of company produces engine. So, engine will be used as a standalone, as if it is available in the shelf, and what are the power required, what are the thrust required, you will pick up the engine and fit in an airplane. If you see other sensors which are there in this aircraft, most of them are not produced here. Of course, of late things are changing, but since you are not making your own such subsystems, sometimes optimization becomes a constrained situation. You wanted something, but you are getting a little different than that, but you have no option, so you have to integrate them and compromise, accept the compromise on your mission requirement. I am sure our country also will produce sensors sooner or later. A lot of efforts are being made. So from wing to engine, and if you see this part, this is another type of landing gear, which you know. We have to also see what should be the width of this base of this landing gear, how much their separation is required. All this thing will come into the conceptual design. Right? You can imagine if the base length is shortened, then it will be on the ground, it will not be stable, it will just topple, right? All those minute things we will take into consideration, but we will not overload ourselves, because finally it has to be something which we should enjoy, right? And relaxed manner, we should be able to do synthesis. And that will be the USP of this course. The pace of this course will be very, very optimally slow to ensure that you enjoy every moment of it. We go back and forth, check with existing design, the concept, validate it, so that after the end of this course, you are confident, yes, at least I know this much. Okay? So we'll be having next class in the classroom. Wish you all the best, and again welcome to this course on aircraft design. Thank you very much.